You may have heard the term trigonometry, and today we're going to do a little intro to trig ratios. Now, a ratio is comparing two things, and in trig ratios, we're going to be comparing sides of a triangle. To begin with, think back to the similar triangles that we were just learning about, and the fact that any two triangles that have two angles the same must be similar. So with right triangles, they all share at least one angle that's the same. So if they share one more, just one, you know that they must be similar triangles. And that means that they also have a proportional relationship between their sides. Well, if you think about it, if I actually were to divide A and B, I'd probably get a number. I'd get a decimal or a whole number, but that number is going to be the same for the smaller triangle as it is for the bigger triangle, as long as I'm looking at corresponding sides. So let's look at an example. Here I have a 45, 45, 90-degree triangle. I have a little one that's 1 by 1, and I have a larger one that's 6 times larger, 6 by 6. Well, if you think about it, 1 divided by 1 gives you a whole 1, and 6 divided by 6 also divides to the number 1. And this would be true if I made it 6 times larger, or 8 times larger, or even a half. A half divided by a half is still 1. So this concept, this idea that similar right triangles will create the same value when we divide, created a whole branch of mathematics called trigonometry. And it's based on this idea that the ratio of corresponding sides of right triangles with the same angles always divide to the same number. And since there are only so many types of right triangles that we would use, so 45, 45 is one example, but you might have 30 degrees and 60 degrees, or you could just start at 1 and work all the way up to 89, and those are basically, that covers it. That's pretty much it. So trigonometry has been a very useful way of understanding the world around us. If you think about it, right triangles can be created in a lot of different ways. So there are 3 trigonometric ratios we'll be using. They're called sine, cosine, and tangent. These are the full names, but in most places, you're just going to see their abbreviations, sin, cos, tan. But when you read them, please say sine, cosine, and tangent. Now, they represent a ratio of the side lengths of any right triangle if we know at least one angle, or if we're working backwards to figure out the angle based on some sides. Sine is when we divide the opposite over the hypotenuse. And that means relative to the angle that is labeled. So in this case, this angle is x, and the side opposite is across. It's the farthest one from that angle. That's our opposite side. The hypotenuse is always the side that is across from the right angle. And that's usually the easiest one to pick out because it's always, always, always across from the right angle. Cosine is very similar. It's just using the adjacent over the hypotenuse. And then tangent uses just our legs of the triangle, but make sure they're in this order: opposite over adjacent. A way to remember this that's been used for years and years, I learned it in school. If you tell your parents that you're learning about trigonometry, they might be able to say it right off the bat, is SOHCAHTOA. SOHCAHTOA. And it's an easy way to remember what ratios go with what letters. So sine is equal to the opposite over the hypotenuse, and the easiest way to remember that is so, of SOHCAHTOA. Say it a few times before you go to bed every night, and you'll have it down in no time. Now, when we actually divide these numbers, so I showed you an easy one where 1 divided by 1 was equal to 1. That's pretty easy calculation, but usually you're going to get decimals. you don't have to memorize what all of these possible ratios would be. In the past, they would create tables like this, and you'd look it up, like the sine of 14 degrees is 0.2419, and then you'd use that in your calculations. But that's ridiculous. We don't do that anymore. Instead, we just let our calculator do the work. Now, a few warnings. If you're using a phone calculator for your homework, you need to be able to find sin, cos, tan as the buttons. You may need to be in horizontal format, so make sure you can rotate your screen. And some phone calculators require you type the number of the angle first. So if your angle's 35, you would do like 35, and then you'd press the button like cosine. That's pretty rare. Usually it's the other way around, but phone calculators can be a little odd like that. Last, and this is true for any calculator, you should be in degree mode, as indicated by the letters DEG, and not rad mode. You'll get very seemingly good-looking answers with radian mode, but they won't be the same ones that we're looking for in our class. You'll learn a little bit more about radians in Algebra 2. So let's do a sample problem. Our job is to find the missing side lengths of this triangle using what we know about trigonometric ratios. The steps you might use, and the first one's a little optional, it just kind of helps when you're learning how to do this, is we're labeling the O, A, and H. O stands for opposite, A for adjacent, and H for hypotenuse. And the first one I usually start to label is the hypotenuse. It's right across from the right angle, and it's always right across from the right angle. So that one's kind of the easiest one. And then you have to think relative to the angle that you're given. So here, this is the angle that was labeled. So my next steps are based off of where that angle is in the triangle. So which side is opposite that angle, and which side is attached to or adjacent to that angle. And that's where I get the O and the H from. It's all relative to where that angle is labeled. Next, I need to decide if I'm going to be using sine, cosine, or tangent. And in this case, because we were given a number for the adjacent side, I'm only going to use ratios that involve the adjacent side. So in this case, I've been asked to find all of the sides of the triangle. One is given to me, the adjacent side. And I'm going to use that information to find side AB. So side AB and the side that I have information about, AC, well, those are the opposite and the adjacent. That tells me, well, which of SOHCAHTOA uses the O and the A? TOA uses O and A. So I create an equation. Tangent of that number of degrees, so I plug the degrees in there, is equal to, in this case, the opposite side was the unknown, and then 12 was the adjacent side that we did know. Now, to solve, you need to know what the tangent of 35 is equal to. And from that table before, you can see that it's going to be a decimal or a whole number. In this case, it was equal to 0.7 almost exactly. And so you might want to just start by typing that part in, tangent of 35, in your calculator, and it should give you a decimal that you can replace it with. Now, if x is in the numerator, we're just multiplying by the denominator to get rid of the denominator, and we have our final answer. So AB was 8.4 units long. Side BC is a little trickier. It uses our adjacent side and our hypotenuse, and that gives me cosine. Adjacent and hypotenuse go with ka of SOHCAHTOA. Cosine of 35 was 0.819 when I typed it in my calculator. But here I have x in the denominator, and that's a little trickier to solve for. One trick is to multiply by x, just like you would the denominator of any other problem, but then it turns into a problem more similar to what we're used to looking at, where we have a number multiplying x, and then we can just divide by that number. Some of you will figure out a shortcut for that really quickly, but you can always go back to multiply by what's in the denominator, whether it's an x or a number, and then continue solving. That's it. We'll see you in class.